All right, we're going to prove that the integral of 1 over 1 plus x squared is the inverse tan of x. So we're going to use trig substitution to do this. When we see an integral, sometimes we can relate it to the Pythagorean theorem in a right triangle. So we're going to try to relate this 1 plus x squared to the Pythagorean theorem. I'll draw a right triangle. I've got theta in the corner. I'm going to call this side x and this side 1. So the Pythagorean theorem would tell us a squared plus b squared equals c squared. So we can fill in the numbers we have. 1 squared plus x squared equals c squared. So c equals the square root of 1 plus x squared. So we could fill that in on the corner, the hypotenuse of our triangle. So that's great. We are going to use a substitution. So thinking about my right triangle, if I think about my SOHCAHTOA, I can see that x equals the tangent of theta, opposite over adjacent. So then I can make my differentials. So dx, the derivative of tangent is secant squared theta, and we get our d theta at the end. So now I have what I need to plug into my integral. So I will replace my x squared with tan theta, and I'll replace my dx with secant squared theta d theta. I am definitely taking up too much room. So this so far looks worse than it was to begin with. But if we think about our Pythagorean identity, we probably, most of us know the sine squared theta plus cosine squared theta equals 1. If you have trouble remembering the other Pythagorean identities, think about dividing everything by another trig function. So I will divide by cosine squared. So sine over cosine is tangent, and 1 over cosine is secant. So now I can go back to the denominator of my integral and replace the 1 plus tangent squared theta with secant squared theta from my Pythagorean identity. So now things get a lot better. Those cancel. I'll move over here. So now I just have 1 d theta, which is easy enough to integrate. So I don't want my answer in theta. My integral started in x. I don't want my answer to be in another variable. So I can go back to my right triangle. I can go back to my substitution for x. I can get theta by itself by taking the inverse tan of x. So now I have the final answer for my integral, and there we have it.